Hi, today let's check if characters of given string can be rearranged to form a palindrome or not. We should return 1 if it's possible to convert the given string into a palindrome, else we'll have to return 0. So firstly, what is an anagram? Suppose we have this string say eat, okay? It can be written as t and it can also be written as 8, right? So basically an anagram means rearranging the characters of a string without adding or removing any characters. It means all characters stay, all the individual characters stay the same, only the positions change. So one another example is, let's say, listen. It can be rearranged as silent. Here both strings have same characters, they are just arranged differently. Now what is a palindrome? Let's take an example of race car. Okay, a palindrome, as you know, if is a string that reads the same from left to right or right to left. So if you read from left to right, it is race car, and if you read from right to left, it is race car as well. So A B C and B C B A. Okay, so this is a palindrome, and palindromes are perfectly symmetrical. Now on to our question: what is an anagram palindrome? Okay, let us suppose we have the string AAB. AAB can be written as ABA, which is now a palindrome. Therefore, an anagram palindrome means we are allowed to rearrange the string such that the final result is a palindrome. Suppose we have S is ABC, we have the string. So it can be written as ABC, BAC, and CAB. Okay. And no rearrangement forms a palindrome in this particular combination. So an anagram palindrome is not possible in this case. Now, why are we checking the character frequencies here? Suppose we have the string S as A, B, and B. We have the frequency of A appearing twice and B appearing twice. So this can be paired as AB and BA. Every character appears in pairs, so they can actually mirror each other. So this can be written like this. Now, why do we need to check the odd frequencies? So we know that even frequencies means it has perfect pairing. Okay, it means that characters on the left need matching characters on the right. So with even frequencies, we are able to achieve this. Now let us take an example like A, B for instance. We have A appearing twice and B appearing once. And this can be written as A, B, A. Okay. If the string length is odd, only one character can stay in the center. Suppose we have S as A, B, C. Okay, we have A appearing twice, B appearing once, and C appearing once. Okay, so a palindrome can only have one center. So more than one odd frequencies breaks the symmetry. So you can't actually make an anagram palindrome with this. You can't have the symmetry like we had here, or we don't have that symmetry like we have here. So let's see the final rules for these. The thing is, if the number of odd frequencies characters, as long as it is less than or equals to 1, then anagram palindrome is possible. Okay, if that's not the case, then it is not possible. Okay, this is the exact reason why we are counting odd frequencies. So the time complexity will be big O of n, as we traverse only once to count the frequencies of each character. And if we are using HashMap approach, then the space complexity will be big O of d, where d is the number of distinct characters. And if at all we are using uh, the approach where we use arrays instead of HashMap, then the space complexity will be big O of 1. So all in all, we have approach, time complexity, and space complexity. Okay, we have the first approach as array approach and another as HashMap approach. So the time complexity will be the same, but the space complexity will be big O of 1 with array approach and big O of d with HashMap approach. So both the approaches run on linear time. The arrow method is used. The arrow method uses constant space, while the HashMap method uses space proportional to the number of distinct characters. So now let's look at the coding part. Alright, let us first code using array approach to check if any anagram of a string can form a palindrome or not. So let us first define a constant for character count. Let's keep it as number of chars 256. So why are we doing this? Since we are dealing with characters, I create a constant of size 256 to cover all ASCII characters. And I also defined a function that takes a string as the input and returns true if palindrome anagram is possible. Now let us create a frequency array. Let's say count is into number of characters. Okay. I initialize a frequency array of size 256 and set all values to 0. Now let us traverse the string. For ch in s, for the characters in the string, count of odd of ch plus equals to 1. So now I traverse the string character by character and increment the count for each character using its ASCII value. Now let us initialize the odd counter as well. So odd count is 0, and this particular variable will track how many characters have odd frequency. Now check odd frequencies. For frequency and count, if frequency modulo 2 is equals to 1, then we increment the odd count by 1. Okay, I scan the frequency array and check if any character occurs an odd number of times. And if odd count in any case is greater than 1, then we simply return false, because as we discussed, if more than one character has odd frequency, a palindrome is not possible, so I immediately return false. Now the final return statement, if we reach here, it means at most one character has odd frequency, so a palindrome anagram is possible, so we simply return true. Okay, now let's go ahead and run this code. As you can see, for these test cases, for A, B, it is possible, so yes, A, B, C, no, race car, yes, and so on. So now let's look at the other approach using the hash map. Alright, now let's quickly code up the hash map approach. So let's create an empty hash map first. Let's say frequency as this. Let's start by creating an empty hash map to store all the character frequencies. Now we need to count the frequencies. For ch in the string, I traverse string character by character. If ch in frequency, then frequency of that character will be plus equals to 1, else we just store it in the hash map. Okay, so basically if the character already exists in the map, I increment its count, otherwise I initialize it by 1. Okay, now let's initialize the odd counter. So odd count is 0. This particular variable, as we discussed already in the previous approach, keeps track of how many characters have odd frequency. So for count in frequency dot values, I now iterate over the frequency values stored in the hash map. If count modulo 2 is equals to 1, then I increment the odd count by 1. It means that if frequency is odd, I increment the odd counter. And for suppose if odd count value at any given point of time is greater than 1, then we immediately return false. We also discussed about this. A palindrome can have at most one odd frequency character. So if this condition breaks, I return false immediately. If at most one odd frequency exists, the string can form an anagram palindrome. So we just finally return true here. Okay, now let's run this code. As you can see, for AAB, we have yes, no, yes, 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 no. Okay. Thanks for watching. Comment down your thoughts below.